Okay, in this video, we will be discussing a problem, simply supported beam having an 18-meter span, and you have a set of 4 loads with 100 kilonewton load leading. Okay, so after 3 meters behind, you have an 80 kilonewton load, then 2 meters behind, you have a 60 kilonewton load, and 2 meters behind, you have an 80 kilonewton load. So this is moving from left to right over the span AB, having a span length of 18 meters. So you have to find two things. One is absolute maximum positive and negative shear and the absolute maximum moment in the beam. So let's start with absolute maximum shear. Okay, for negative shear. So we already know the diagram for a simply supported beam. We have the ILD for shear force like this. And if you extend this further to a point B, you are getting the maximum ordinate 1. And this is the maximum value of negative shear. And when you extend the top ordinate to point A, you get maximum ordinate of 1, which gives a maximum positive shear force. So referring or utilizing this ILD, I'm going to sketch the ILD here, which is shown in red. And for getting absolute maximum shear, the set of loads with the leading load should be on point B. At least one load should be on point B. So keeping that in mind, I have positioned the loads according to their spacing, and this is what we get. So the ordinates corresponding to 100 is 1 because that's the maximum ordinate. For 80, I have given y1, 60 is y2, and 80 is y3. So 3, 4, 5, 6, 7. So this much is 7. So that means 18 minus 7, 11 meters is the rest of the spacing. So now from figure, absolute maximum negative shear is nothing but the point load into its ordinate. So 100 into 1 plus 80 into y1 plus 60 into y2 plus 80 into y3 is the absolute maximum negative shear. Now you have to find what are the ordinate values y1, y2, y3. We already know that 1 is a maximum ordinate. So from the principle of similar triangles, y3 by 1 is equal to 11 by 18. So y3 you got as 11 by 18. y2 is 11, 12, 13. So 13 by 18. y2 is 13 by 18. Similarly, y1 is 15 by 18. So like this, once you have found all the ordinates, absolute maximum negative shear is, substitute the ordinate values, and you have got 258.88 kilonewton as the absolute maximum negative shear. Coming to positive shear, for positive shear, we saw earlier in this diagram, you have to place all the loads at A with the last load at A. Okay, that is how you can position. So I have drawn a separate diagram showing the positioning of the load. So I have kept 80, the last 80 kilonewton load at A, and then the rest of it is spaced in such a way that you get this kind of arrangement. Okay, and the corresponding ordinates are also shown, and hence the absolute maximum positive shear is nothing but load multiplied by the ordinate. So 80 into 1 plus 60 into y1 plus 80 into y2 plus 100 into y3. Okay, so what is y3? 11 by 18. y2 is 11 plus 3, 14 by 18. y2 is 11 plus 3, 14 plus 2, 16 by 18. And y1 is 11, 1, isn't it? So last one is 1, and y1 is 16 by 18. So like this, you have substituted all the ordinates, and finally the value is 256.66 kilonewton. So this is regarding absolute, negative, and positive shear forces. Absolute maximum values are found out. Now the second part of the question shows absolute maximum moment in the beam. So you have to find the absolute maximum moment in the beam. So the second one is absolute maximum bending moment in the beam. Just remember that it is not at a section. You have to find somewhere that you have an absolute maximum bending moment. So it is important to find from the previous derivations what we had learned is you have to find the resultant, right? The resultant of set of loads. Okay. Then, so in order to find this, you let us take moment about the leading load 100. Taking moment about the leading load, which is 100 kilonewton, what we get is the distance, of resultant from that leading load of 100 kilonewton. So let me represent it as small a is equal to 80 into 3. Please refer to the figure. Okay, you have 80, 60, 100, another 80 and 100. So 80 into 3, the second one, we are taking moment about this 100. So 80 into 3 plus 60 into 5 plus 80 into 7. Okay, whole divided by, of course, 100 into 0 because there is no distance to 100 divided by 80 plus 60 plus 80 plus 100 because sum of all the forces should be taken. So simplifying this, you will get 3.4375 meters, which means the resultant of this set of 4 loads is placed at 3.4375 meters from the 100 kilonewton load. So I will show the position here. So these are your set of loads. This is your leading 100 kilonewton load. After 3 meters, you have the second 80 kilonewton load. After 2 meters, you have 60 kilonewton load. And finally, after 2 meters, you have the 80 kilonewton load. So this is 3, 2 and 2. So where is your resultant? You have got your resultant at 3.4375. So this is your resultant. And from here, it is 3.4375 meters. Okay, this much is understood. Now you can observe that your resultant is very close to the second 80 kilonewton load, isn't it? So it shows that maximum moment is likely to occur under this 80 kilonewton load. So what you have to check next is resultant is close to the second 80 kilonewton load. Okay, so we had discussed in the derivation that we will choose one particular load as a critical load and we will be placing that adjusting the resultant. So you know that your resultant is close to 80, which means you can choose a second 80 kilonewton load as a critical load. So we can infer that maximum moment, absolute maximum moment is likely to occur under the second 80 kilonewton load. Okay, this is what we infer. So let us find out what is the distance between load and the resultant, which was represented by the letter small d. That is equal to 3.4375 minus 3. So that is equal to 0.4375 meters. So you got small d as 0.4375 meters. For maximum bending moment, how should this load be placed? It should be placed at a distance of L by 2 plus D by 2 from point A. Okay, that is what we learned in the derivation. So for the maximum bending moment, this load or that 80 kilonewton load should be placed at a distance of L by 2 plus D by 2 from end A. Okay. So we have to find out what is L by 2 plus D by 2. So L by 2 is 18 by 2 plus D is, which you have already found out, 0.4375 by 2, which is equal to 9.21875 meters from point A. Okay, so this is how you will position. So now you have got the condition for maximum moment. So if this is your set of loads, 100, after 3 meters, 80, after 2 meters, 60, after 2 meters, 80. Okay, now how you have to place it? So your 80 should be under 80, you are going to get your maximum. So from there, we will start the maximum ordinate. You can show your simply supported beam, 18-meter beam. Okay, this is the ILD, by the way. So this is a maximum ordinate, and from end A, it is placed at a distance of, you have already found out, 9.21875. Okay, so you can find out 18 minus this, you will get 8.78125. You need not take these many decimal places. You can make appropriate, approximations. Okay, So let us take the ordinates under the loads, and that is what you have to find out next. So this is y1, let this be y2, and this is y3. Okay, this is A and this is B. Now you already know this distance, and you know that this is 2 meters and this is 2 meters. So this minus this will be, this will give you this distance. So let us find the maximum ordinate is given, which is yc is given by z into L minus z by L. Here z is 9.21875 into 8.78125 divided by 18. So this gives you 4.497 as the ordinate. So therefore, absolute maximum bending moment is equal to 80 into y1 plus 60 into y2 plus 80 into yc plus 100 into y3. So this is equal to 80 into 5.21875 divided by 9.21875 into critical one 4.497 plus same thing here 60 into 7.2185 divided by 21875 divided by 9.21875 into 4.497 plus next 80 into nothing but 4.497 plus 100 into y3 is 5.78125 divided by 8.78125 into 4.497. Now simplifying this, you need not, if you are feeling very difficult in writing all these big things, then you can individually find out y1, y2, simplify it and then substitute the final value here. That is also fine. Okay, this simplifying you will get 170.77 kilonewton meter. Okay, just try it at home and see if you are getting the same. In the next video, we will tackle another problem. Okay.